It's like perfect. All right, Reese, you asked for the first question. Which was what? 10?
Yes, please.
10. Okay. This is off of 2B. Let's take a look. Where are we at? Oh, sweet, no story problem. We get to learn a little story. Yeah, love this stuff. All right. Suppose you want to join a gym. This is a good story. New Year's resolutions, all that stuff. Colorado Athletic Club charges an initial fee of $480 plus $40 per month. 24-hour fitness charges no initial fee, but costs $55 a month. Okay, so you're trying to make some sort of choice on which gym to go to. I believe probably don't want to join both of them. It says write an equation for the cost C for joining Colorado Athletic Club. Okay, all right. So hang on. I think we can do this. So this is number 10, right? So Colorado Athletic Club, CAC. Okay. So they charge you $480 just up front. You're committed to $480 immediately with this place, right? And then how much are they going to charge us a month? 40. So they're going to charge, this cost is going to happen no matter what. But they're going to charge us then $40 per month. Okay? We can say this is the cost. The cost is $40. Each month you're there, they charge you another $40. But that $480 is there no matter what. And then 24-hour charge is what? What's 24-hour charge? 55. Do we have to worry about any upfront money? No. No. So how much is nothing? 0. So we don't have to come up with anything to join 24-hour fitness, but the cost is going to be $55 per month plus 0. Do I need that plus 0, really? Okay. So we're not using X and Y. We're changing the variables to C and M for month and C for cost. But it's one of those you might have to identify for yourself. So so we have that's the answers to A and B. And then how many months would you join for the price to be the same? So being that we're paying $40 a month here, but we had to cough up $480 originally, Colorado Athletic is going to cost us more in the short run, but the longer we stay members, this would actually probably become less money in the long run. So like if you're going to live in a place for a year, you might choose to do the 24-hour fitness because it would be less probably in that year's time than the Colorado Athletic Club, just because of that $480. So let's, can I do this? Is this okay? Yeah. Okay. So we're using substitution, correct? Mm-hmm. What can I substitute? 55M for what?
40. 40M.
What letter is that?
Oh, put
what letter is that?
Equals 40M plus 40.
There you go. There you go. So that is going to go right in there. Okay? So that gives me 55M. It was C, but I'm going to plug it into the other equation. So I get that. Okay. Where should I go from there? Subtract 40M. I like it. How you doing there, Cupcake?
I'm great. How are you?
Doing well. He's not here anymore.
Still?
Well, yeah, he's still ditching.
All right.
Someone said that he stayed on the bus and he. Just kidding. See you, sunshine. See if he ever comes back here. Guy called me Cupcake. Do you agree with that?
Yes.
How do I get M by itself?
Not by 15.
Divide these side by 15. Someone have a calculator out real quick?
Yeah. Yeah, I have one.
What does it say? 32, thank you. So, at 32 months, so once you have been a part of this, if you were trying to, do a comparative analysis, at 32 months, Colorado Athletic Club and 24-Hour Fitness, you've paid the same amount of money that you've invested. Now, as soon as you go to the 33rd month, Colorado Athletic Club is now cheaper as that long span of events has taken place than 24-Hour Fitness. I don't know, some people might. I'm just saying.
Well, like, most people like break shows. Like, if your New Year's resolution was to work out a couple of weeks.
And you're absolutely right. I go to the rec center by my house. They have nice facilities, and there's a handful of us dads that all work out there, and it's just kind of our social time, but we enjoy it. And it's just now it's kind of saturated because you got all these people. I'm gonna burn off those 12 pounds I put on over the holidays. Okay. See if it lasts a month. No, you're absolutely right. Most people, and that's what a lot of times these athletic clubs are banking on the fact that you won't. People aren't disciplined enough to do that. So.
My mother was saying that we should open a gym, but after the first 2 weeks of the new year, it turns into a bar.
Yep.
Because, like, nobody ever actually works out.
Yeah. Well, I just work out at home. Giddy up. Hey, did we have someone else ask me about it? Jeremy, was you asking me about one of the questions? Number 2. Okay. All right. Do we feel okay on number 10? You feel okay there? All right. Let's see. Number 2. Number 2. Okay. Here we go. Let's talk. How can we do this? What do we know? What do we know right away? What's a real good given on this problem? X equals y. So wherever I have an x, I can put in a y. Or
If you have a line, never mind.
yeah, no, say it.
If you have a
Speak
line,
it. Speak it. So wherever you have an x, you can put in a y, or wherever you have a y, you can put in an x. You have to choose which way you want to do that. So do I want to replace the x here? Would that be okay? Or should I put this in there? What do you think? Any ideas? Here's a question. If x is equal to y, once I solve for one of them, do I know the other one right away?
Yes.
Yeah. Okay, so you have to choose. Do I want to plug the x in for the y on the other equation, or do I want to plug the y in for the x? And it's your choice. There's not a right or wrong answer. Okay, so I'm going to keep the 2y as is. I had an x there. What's going to go right there? I'm going to put a y. How do I get y by itself? Subtract y. That's the same thing as 1y, right? I can do y equals, and if you know that y is equal to 3, x has got to be equal to, x got to be equal to x, you're correct. But being that y and x are equal to each other, and we know that y is equal to 3, x has to be equal to?
3.
See, I was waiting for you to say x again, and I was going to laugh. Yeah, x has to be equal to 3. There's our answer. 3 comma 3. Sweet. What else have we done on this? Anything you want me to talk about? We good? No? Yes. 8. Yeah, buddy. All right, number 8. Number 8. Ooh, we're graphing it. Okay. Okay. Just graphing it, right? So let me modify this one to look like this. And what? Help me out, Ben. What did I just do right there? I just put it in slope-intercept form. Mx plus b. Y equals mx plus b. So if I draw my xy axis, the y-intercept is -5. And from there, I'm going to do what? What am I going to do from -5? Help me out. Some of you are socializing too much.
Oh, 2 over.
You what?
Go to.
Just do it. Yeah, it slopes a map, right? So from here, I'm going to go up. How many? 2 and what? To the right one. There we go. Okay. And then, so I modified this problem to look like this. What's my first thing I plot there?
Go up to.
Yeah, my y-intercept is +2. Help me out.
Go down 5.
From that point, I'm going to go down 5. So I'm going to go down 1, 2, 3, 4, and 5. And then what?
Right.
Hey, look at that. We got lucky. What does that look like? 1, comma, -2, maybe? -3. Okay. All right. I help you out. Any others? Or we go? Okay. Yeah.
Reading number 7.
I'll do it for you, buddy. Number 7. Another graphing one, right? Angela, thanks for asking for this one. This is a good one.
What do you want?
All right. Shh. What's my y-intercept there? Huh?
-2.
-2? So I'm going to go down 2, put a dot. What is my slope?
That's
1 over 1.
1 over 1, right? So from this point, I'm going to go up 1, right 1, put a dot. Still with me? We're going to draw the line as straight as we can. Okay. But the second one is not set up in slope-intercept form. It's in standard form. In standard form, we use a method that is what? Cover. All right, so let's cover. So I'm going to cover the y. X is equal to? 2. Wait, squeak. What was your puberty?
2.
Okay, and then I'm going to cover the x. And I get y equals?
2.
Right? Yes? I think the answer to this is 2, 0. What do you think? Does that seem okay? We good? We happy? We content? Poke your neighbor in the eye, tell them to be quiet, make sure that everyone's cell phones are off. All right. Okay, let's see. How should we go about this? Megan, we started out before break, and we talked about graphing 2 lines. But what is something that we might have started to go over of why graphing might not have been a good approach to solving where 2 lines cross? The F word, the big one. Yeah. Fractions and decimals could be where your intersections take place. And fractions and decimals are sometimes hard to figure out where it exactly goes to get the answer. So, George, if I have 2 lines graphed, what's one event that could take place with those 2 lines graphed on the same plane? What could happen with 2 lines graphed? They could intersect. And if they intersect, how many solutions do you have? 1. And how would you label a 1 solution? Would you like just put 6 and be good? Or would it be Is it a single value? Is it a point? Is it another line? So if I have these two lines crossed just like that, where they cross at, how would you identify for me where they cross? Other than circling it or saying right there, how would you identify it? Say it. Tell me.
As a point on the graph.
It's a point on the graph.
So like x, y.
You got that, George? Okay. All right, so George, we're going to pick on Angelo next. Angelo, if one of the events was two lines could cross each other, what would be another event that could take place if two lines were graphed on a graph? They could be parallel. And do parallel lines cross each other? No. So Angelo, your parallel lines have a solution? Nope. They don't cross. So if you have two lines that are parallel, which means they would have the same slope, they won't cross each other. That means they won't have a solution. Garvey, last one. So we talked about them crossing each other. We talked about them being parallel. What's the third scenario that could take place? Same line, same position, which has how many solutions? Infinite solutions. So we could have this, which is one solution. We could have this, which is no solution. And then we could have this right on top of each other, which is infinite solutions. So if you had this answer, you have it labeled as x comma y. If you have this, what do I put for an answer? No solution. And if I have this, I put the infinity sign. Okay, so, but then we talked about on substitution. We talked about substitution. If they crossed each other, we could solve for both x and y. We could solve for either the x or the y, plug it into the other, get the first answer, then go back to one of the original problems and find the other answer. And then what happened if they were parallel, though? What was a silly thing that would happen if they were parallel, meaning they'd have no solution? What indicated for you once you solved your problem that it has no solution? What was weird about it? It was like you solved the big miss. Stevie. Yeah. So this could be like 7 is equal to 15. And we know that 7 is equal to 15. We didn't discover some, weird thing that happens in life. So if you happen to go and use the substitution method and you get one number equaling a totally different other number, okay? And let me ask you this, because sometimes on a test you got to change this. If I have -5 equal to 5, is -5 and 5 the same number? No. One's positive, one's negative. Completely different numbers, okay? Hey, Steve, come back to you. If this one was the strange one where you had one number equal to another number, what would have happened here to identify that we would have? I will tell you that all of the letters are going to fall out as well. And you're going to have some numbers. But what do you know about those numbers on each side of the equal sign? Say what? Ben, you remember?
They're the same number.
Same number. So this would be a truthful statement. So you could have 7 is equal to 7 or 15 equals 15. Okay? And we'll cover that more. So I'm just trying to go back and make sure we remember. We have the graphing scenarios that we took place. Graphing cross, you get one solution. Graphing parallel, no solution. No solution, if you use substitution, you get all the letters that fall out, and you get one number equal in a totally different number. And then, if we have the same line, we know that it has infinite solutions, and that gives us a true statement where all the letters happen to fall out, but it's a true statement. So I can't emphasize enough. I think on Tuesday or Wednesday, ooh, hang on, I got a calendar right here. I can look. Nope, I lied to you. I'm sorry.
Oh, God.
It's on Thursday. On Thursday, we are definitely going to have a quiz. And I imagine a question on the quiz might say something like this. Bo worked out a problem. All the letters fell out, and I wound up getting 8 equals 9. What can Bo conclude about his answer?
It has no solution.
It has no solution. So, Kieran, if there's no solution, if they were graphed, what would that graph look like as far as the 2 lines? Giddy up, parallel. And then Celine might be part of a word problem, though. It says Celine was working out a problem. And she realized that -6 is equal to -6. What can Celine conclude about that problem? Infinite solutions. If it's infinite solutions, Mac, what do they look like graphed?
Oh, they're on the
Same line. Okay. So that's going to bring us up to today. So we started with graphing, and we realized graphing might not be the best method because it is very possible that we don't graph really appropriately. It is very possible that our solution, the x comma y, comes out to fractions or decimals, which are harder to figure out. Substitution also works pretty well, but substitution works pretty well as long as you can solve for a letter easily. Does that make sense? So substitution, let me clear this real quick. Substitution works really good if you can do this. Could I solve for one of the letters pretty easily on this? Yeah, what could I solve for?
X.
I can solve for x by doing what, TJ?
Subtracting.
Yeah, so if I subtract 5y, I can get this. And if I have this, that means anywhere I have an x on the other solution, I can plug 8 minus 5y in. Okay, so substitution, if you can solve for a letter easily, works nicely. Okay? And I'm going to pick a random problem, or I'm going to pick a couple numbers or a couple of problems, and I'm going to show you how sometimes they can't always be solved easily. I can't really solve for a letter real easily. I could solve. I mean, if I were to take the top equation and solve for x, I'd have to subtract 5y from both sides. Then I'd have to divide everything by 3, and whatever that came out to be, I could plug that value into y, and it becomes a fraction, and a big fraction. Okay, so I want you to see this real quick, and then I'll erase it. If I wanted to solve for x on this problem, if I wanted to solve for x, I'm going to wind up with this for an answer. Wait. Screwed up already. Sorry. So that's what x is equal to on that first problem, which means I then would have to take this right here, and I'd have to plug it in right here, which is going to give me which, if I went and started working it out, this would give me 12 over 3, that's 4. I'm doing it in my head, minus 10y over 3 minus 7y equals 8. I don't know about y'all, but this is one that's getting a little nasty, and most of you aren't seeing the step from there to there because I did a little bit in my head. So substitution, if you can't solve for the letter easily, might not be the best method to use. Graphing is probably not going to work. If I use the cover method here, yes, I'll get x is 2 and y is 6 over 5. Yeah, good luck graphing that. And then here I get x equals 4, that's fine. And then y equals negative 8/7. Yeah, good luck graphing that and get them to figure out exactly where they intercept each other. So let's clear this down. Let's find a simpler. All right, we got office coming up. Love you. Get out of here. Sweet. All right. So there's going to be a third method I want to show you. This third method is A lot of times students want to steer away from it because they think it's too hard to do. But you remember I told you that math is a puzzle. It's a logical puzzle. The logical puzzle is you going through and doing manipulations in order to get a solution. That make sense? All right. So, who should we pick on? Casey, I'm picking on you. You did nothing wrong, but I'm still picking on you. Casey, I just want you to tell me which letter to solve first. X or Y. Your choice. X. Casey chose X to solve for. Okay? So I'm just going to put over here that we want to get X solved for. Still with me? All right. So if I were to add these two equations together right now, if I were to add these two equations together right now, I would get 5x minus 2y equals 14. Do you agree? All I did is literally I went 3x plus 2x, 5x, 5y plus negative 7y, negative 2y, 6 plus 8, 14. So did any of the letters fall out by me doing that just now? Okay? So Mackenzie, we're solving for x. Still with me? We're solving for x. So that means I want to try and eliminate y. Okay? So I just said if we add these two equations together, I get 5x minus 2y equals 14. So that's the way we're going to go through this problem. But this is what I have to do. I have to figure out a number that 5 and negative 7 could become, when added together, that would cancel out each other. Okay? So 5 and 7, negative 7 right now, do you agree, are the same number or not the same? Okay? Everyone agree? All right. So what is the smallest number that both 5 and 7 go into? 35. Yeah? 35? Sound good? So watch this. What would I have to multiply this whole top one by to get the y value to become 35? 7. But I have to multiply everything. So I'm going to multiply here, and all the way to there. So 7 times 3x is 21x plus 35y equals 42. Is that okay? Now Tristan, what do I need to multiply that bottom equation by to get the y value not only to be 35, but it has to be an opposite sign? Meaning, the one on top right now I know is positive, so I want it to be negative. So, hang on. I prematurely asked you a question. I apologize. Right now, that and that are opposite signs. Agreed?
Yeah.
So I don't necessarily have to go and change, like multiply by a negative value to change the sign, but I can just multiply by a number because they're opposite signs. So 5. I like it. So if I multiply this entire problem, a couple of you are goofing around too much. Here and here and here, this problem is going to become 10x minus 35y equals 40. Okay. Now, okay, if I add these two equations together right now, does it look like the y's will cancel each other out? Yeah, they are the same number, but they're opposite sign. Do you agree with that? So one's positive, one's negative, and they're the same. So right now, if I add my two equations together, if I add those together, what is 21x and 10x added together? 31x. What happens to this and to this? They're gone. And 42 added to 40 is 82. And how do I get x by itself? Divide by 31. Oh my goodness. And 82 over 31 does not reduce. So that is one of my answers. Now, of course, the ones that I am choosing to do, they're going to come out as ugly answers. And they're going to come out as ugly answers for a reason. I want you to realize that this method works really well. Do you feel that it would be pretty easy on a number line to find 82 over 31? No. It's not a whole number. But my first value to my solution to this problem is that. Okay, Reese, did I solve for x or solve for y?
Just now you solved for x.
Solve for x.
Yes.
So what would you feel we should do to solve for y now that we know that x is equal to 82 over 31?
Wouldn't we have to put the 82 over 31 in the x position?
Yep. I like it. You hear that? Wouldn't we have to put the 82 over 31 in the x position? What color is our original problem, Reese? What color?
Green.
Green. So I am going to take this here, and I'm going to plug it in either here or here. Choose one.
The top one.
Top one?
Yes.
Sure. I like it. And it's going to give me the same answer as the bottom one.
Oh.
But take a look at the bottom one. Why do you think I'm kind of getting you to sway that way a smidge?
Because it would be easier.
It is easier. And here's why. I'm multiplying by 2 versus 3. Okay? So if I choose this one, choose this problem here. Now, your answer would still have been the same if you would have plugged in the top. But the only reason I said it is, oh, multiplying by 2 is easier than multiplying by 3. That's why I chose it.
All right.
Okay? So this is 2 over 1. So 2 times 82 is 164, holy cow, over 31 minus 7y equals 8. Are you kidding me? Oh my gosh. Now, again, I'm giving you about the ugliest scenario you could ever come across on these problems. This year, yes. These kind of answers are actually more realistic answers that will happen, like if you were to actually be using this type of math in a work field. You know, a lot of times when you do some math, it's not like you come out with a nice, oh, it's 5 for an answer. Yeah, 3 point.
And you have to keep.
Yep. I understand. So this, you know how I would choose to do this problem? Does anyone remember how to do this problem? If we have a denominator, what do I do to get rid of the fraction? George? What do I do to get rid of the fractions? How do I clear the denominator? What's my denominator on that ugly green thing? 31? Good, you threw your voice. So if I do this, I'll multiply this by 31, and this by 31, and this by 31. You know what's cool is that fraction's now gone, and I get 164 minus 217y equals 248. Though that's pretty ugly, I no longer have the F word. How do I solve that? Subtract 164 from each side, then I'm over 270. Right. Angel, you got a calculator on your phone right there. Do me a favor, just so we can get through this quicker. Ready?
Yeah.
248 minus 164 is 84. And then I'm going to divide it by negative 217, so that just is this. Thank you. All right. I'm pretty sure if we had graphed this, the only person that would probably get this correct would be Steve. because I know that Steve's precision on graphing is awesome. And he can tell you where 82 over 31, comma, negative 84 over 217 is exactly on a graph. It's amazing. It's a skill I've never seen before. So other than Steve, all the rest of you might choose to do this a different way. So graphing is a nice way to solve, as long as it comes out to nice small numbers, whole numbers. Okay? Substitution works really well when we can solve for one letter or another on one of the equations and substitute it into the other equation. But then if it just doesn't work in a pretty kind of way, elimination is a good way to do it. So I was going to do this. If you have your homework, let's work out number 2. If you have your packet, if you don't, I'll copy this down and it'll be one of the problems. It's on page 128, which is 3A.
246.
Is there a work?
There will be.
Gross.
Oh, what's that new workbook number?
Homework is gross.
CP Algebra. It's coming. Where's
Like $3.
$4 or $5? Sorry. I should know that, but I don't. Apologize. We can still use the old book. Probably up through. We can still use it up through next week. Yeah. Next week, week after. Yeah. All right. Take a look at this problem. This is problem number 2. So I want us to think this way real quick. Ray, do you feel if I add these 2 equations together as they sit, one of the letters is going to go bye-bye? Okay. Look at my x's, though. I agree. But I agree with you. I agree with you. Your thought process is absolutely correct on this. And Ray had said multiply the bottom by 3, and if I did that, the y's would cancel out. But right now it's set up that if I add these 2 equations together just as is, look at what happens to the x's. They're gone. 3y minus y is 2y. 11 minus 9 is 2. Y is equal to? Sweet. Bless you. Now I'm going to take that y value, and I'm going to plug it in where? What letter am I solving for if I already know y? I know what? I need to find x. So I'm going to take that y value, Christian, I'm going to take that y value, plug it in either here or there. Top one or bottom one? You pick. Bottom, I like it. So I'm going to go 4x minus, there was a y there, what am I putting there? Putting 1. Okay, I'm going to add 1 to both sides. 4x minus is equal to negative 8 divided by 4. X equals negative 2. But Mr. Sturp, you said if we get nice little answers, we could have graphed these. You're right. You're absolutely right. So I'd probably choose to use the cover method on the top one, and I'd use the cover method on the bottom one, and then where it crosses the x on the top one is negative 11 fourths, and where it crosses the y on the top one is at 11 thirds. And then on the bottom one, it would cross the x at negative 9 fourths, and on the bottom one, it would cross at 9. Oh, finally a whole number. So though we even came up with nice answers, it still doesn't mean that graphing would have been the best solution to do this problem. May I move forward? Still with me? Let's do number 5. Number 5. Can I erase this? Yeah, buddy. All right. Clear and ink. Number 5. Kenzie, help me out. When you see this problem, if I were to add the 2 equations together right now, does a letter cancel out? that okay? Does that make sense? Bo, did you get that? She shook her head saying no. So if I add these two equations together right now, a letter's not going to cancel out. Okay? Gage, picking on you now. I want to solve for x or y. Now, I'm kind of leaning towards the y. And the only reason I'm leaning towards the y is I note that I have a positive y and I have a negative y. That's the only reason I'm leaning towards the y. Does that make sense? What's the smallest number? That 4 and 6? No, between the two.
Oh, between.
Yeah, at least common multiple. Your age in 6th grade.
Oh, like multiplying versus
12. Yeah. So 12 sounds like a. 12 sounds like if I were to choose the number, make the number 12, what would I have to multiply the top one by to change 4y to 12? 3. If I were to make the bottom equation 12, and it would be negative 12 in this case, what would I have to multiply the bottom equation by in order to get there? 2. Now, some of you are looking at it going, yeah, but that one problem you've done, you multiplied them together, so you got to use 24. That's absolutely right. You're going to have the same answer regardless. It's just sometimes there might be a smaller number, and it's easier to multiply smaller numbers together. So if I were to eliminate the y's, one reason I'm choosing to eliminate the y's is they are opposite signed right now. And if I were to, on the top equation, multiply the whole thing by 3, and then on the bottom one, I multiply the whole thing by 2, if I distribute here, here, and here, on this top one, I'm going to get 9x plus 12y equals 33. And on the bottom one, I distribute here to here to here, I'm going to get 10x minus 12y equals 62. My newest student, what's your name? I forgot. Ashley. If I add these two equations together right now,
So 19x and then the 12x or 12y negative 12 cancel out.
yeah, they cancel out. Good, I like it. And then I'll do it for you. 95.
Yeah. Then you divide by 19.
Divide by 19, and it comes out to what?
And that's not divisible. So
It's
just
not? Is it? I don't know.
I don't think it is.
God bless you. Is 5 times 19 95?
Sure.
Is it?
Sure.
Huh? 19 times 5?
Yeah.
Yeah. So this is a hard one. You're using 19. So that comes out to what? 5? Sweet. We have an x is equal to 5. I was with you originally, going, I don't know if this is gonna reduce. I was thinking because it came out of the book. It's
It
probably.
doesn't look like it,
I
but
agree.
it's kinda-
I agree. Hey, is that an x or a y value?
That's a y.
Oh wait.
It's in the y.
It-
Well, it's x,
I-
but you put it.
I put it in the wrong spot. I tell you, Philip. Get out of here. Get out of here. That's an x value. I can plug it in here or here. I'm just going to pick one. Pick the top one. You should know that your phone's broken. Should be out. Ooh, busted.
Sick bird though. Bird sings hello.
Worked out nice. Guys and girls, you know, it's just about time to skedaddle. We got about a minute and a half left. I would like you to work on worksheet 3A. It's page 128. It's only one side. Number 3A, it's page 128 at the bottom. It's only one side. We've already done 2 of the problems. There's 9 problems total. So that means you have only 7 left to try.
58.
Good? Happy?
Great.